Hello, and welcome back to another episode of Forgotten Gear Restorations. I'm your host, Dr. Stephen Hawkins, and I bring terrible news. Frank has been kidnapped by Guitar Center management. Since I'm stuck in this pickle jar, I'll just carry on without him. We are tackling a revision G Mesa Dual 3-channel dual rectifier with channels switching issues. It's the tale as old as time, but on this occasion, the JFETs aren't at fault. Randall Smith is. He doesn't love you. He's never loved you.
All right, guys, top of the morning, and apologies for that what would appear to be an unhinged rant that was replete with evidence of unorganized thoughts. In other words, I just had to get it out. So, you know, this is not a negative channel. I always find a way to make lemonade. You know how I do it. Speaking of making lemonade, Mesa Boogie dual rectifier solo head. What's it doing? Well, I don't know. Let's start from scratch. Let's just start from scratch. I don't have the foot switch, so we're going to be relying on the little rotary switch on the rear to take us through some channels. I do have signal generator set up into the input. Let's get her warmed up. I've got the old Dynascan 1655 isolated variable AC power supply set to reflect a wall voltage of 117. Why? Because I just feel weird today. Why is it not 120? It doesn't matter. Current limiter is on. Let's get her warmed up. Let's start off on clean. If I can do that. Can I? Yeah, I can. Oh, bloody hell. We're just going to go for it like this. Right. Let's just start with where we are. So we have output. It says we're in channel 3. Put the output about midway up. Wind the gain up. Master is up. I'm getting exactly 0 signal. Current limiter tells me that the amp's power supply is happy. Let's stand by. So I just noticed something. Channel 1 is illuminated, and so is channel 3. We got some JFET action here, or what? Let's open this girl up. Okay, so just take a look here. I'm just gonna put a little bit of torque on the channel switch rotary knob. See that? So let's hope we have some broken traces back there. I just got to get inside of this old girl. All right, so here's the area that I'm concerned with. Right here in front of my middle finger is the channel switch knob, the rotary. That board sits underneath this rear input-output board. It's under there. There's ribbon cables. All right, here's the rotary switch. This end of the ribbon cable goes underneath the little input-output board here and connects right to that printed circuit board on the back. I'm hoping that we have a broken solder joint there. And again, that I'm not going to be hunting for shorted JFETs. All right, and of course, because it's Mesa Engineering, you can't remove this switch without removing the circuit board. So that's where we're going next. All right, well, here's that switch. And I don't have jaundice. It's just the way the lighting looks. I'm not seeing anything broken. I'm just hoping it's dirty. But this is 100% sealed. But there's a lot of play in the shaft there. This was securely fastened to the rear panel. I'm going to go ahead and just make some I'm gonna freshen up these joints here, and we'll just pray together. You need stability. You're not just gonna solder it like that, are you? No, you're not. You got a magnetic parts bin.
That's a tray, jackass.
And then you have your stability there. All right, well, did it do something? I don't know. I just need to do that to rule it out. And it just takes like 5 seconds, right? Boy, I got a feeling about this amp. I got a feeling. I got some kind of feeling about this amp, I'm telling you. Okay. Okay, so these joints look good now. There was one that might have been a little dry, but doubtful. Doubtful that that's what was doing it, if anything was doing it. So somebody asked me, hey, how do you clean a sealed switch or a pot like that? What do you do? Well, sometimes the only option you have if you can't physically open it up is to just try to shimmy some fluid down the shaft there and just work it. And you just hope that it sort of pulls up over the contacts there and the switch element, and then you could rub it out. But it doesn't always work out that way, does it? No. But sometimes it does, and then, you know, you just got to go for it. That's all we can do. That's all you can do. I could actually feel it. I could feel it making a difference. You can actually hear the fluid changing the sound of the switching. All right, so. All right, the joints look good. It feels a little gritty still. It's got a gritty feel to it, man. I hope this. Oh, dude. I hope it's. I need to figure out where the input pin is on this thing, and then I can test it with my meter. Right? Look at this. Is this? I don't know if this little wafer is ceramic, but it looks like a chunk is just missing from that point. Right there, you see that? All right, so what am I going to do now? I am going to lightly do a light reassemble and a function check. All right, guys, so she's back together after that one test, and let me see if I can get you guys to be able to visualize the channel indicator lights, and maybe you can. Well, you can see the clean channel way over here, and then channel 3. The good news is that there's no more intermittency with respect to the switch. So it's only switching channel 1 on and off. You see that over there? The good news is that the switch is no longer the issue. That's the good news but you want to see the other news. Every one of these little orange boxes could be affiliated with the switching matrix. Any one of them, rather. But maybe Boogie did something right. I don't know. I need to inspect the low voltage supply before I make any other assumptions. I just wanted to see. And this is the same construction style that you get on the F50. If you look at what they're doing, this board right here that the power tubes are sitting on, I'm probably going to have to remove that and reflow it because I see a lot of suspicious looking joints there. And how does Mesa Boogie... Well, you're thinking, first of all, sorry. You're thinking, oh, chassis mounted tube sockets. That's great. Those are super sturdy. Well, it's not really the case. These are mounted on a PC board. And the worst part of it is in order for them to retain the PC board and the chassis and the PC mounted sockets, the way they retain that orientation with the bottom of the chassis here is they literally press and smash and squeeze and flex the circuit board around the sockets in order to create enough tension to hold the whole thing in. So you have a tremendous amount of pressure once you torque these little screws down that are holding the thing into the chassis. It's literally bending and flexing that printed circuit board around the tube sockets, each one of them, in order to maintain its position and stability. That's an incredibly irresponsible way to mount this particular board on an amp this expensive. So I'm not being negative, I'm just being real, because this whole consumer cannibalism thing that I had referenced with Guitar Center yesterday, and boy, I got some nasty grams about that post. This whole thing deeply bothers me. Whenever I see musicians and artists taking advantage of other musicians and artists, it just lights me up, man. And I feel that that's what this is. What else could it be? Let's get back to the technical aspect of this assessment. Now, proximity doesn't always tell the story with Boogie because something that may be involved with switching near the actual jack for the foot switch, a component of the switching matrix that should be right there, localized to this area, may be on the opposite board, connected with a ribbon cable, and then on the exact opposite end of the chassis. I've seen it a billion times with Mesa Boogies. The layouts don't seem like they make much sense. All right, but maybe one of these JFETs, because it says SW on it, is one of the switching ones. Maybe this guy right here shorted, or maybe this tantalum capacitor back here, that yellow guy with a conical end on the eastern side. Maybe that guy shorted. And you want to know what? That's oftentimes a huge issue for like the Mark II or III series on up through these guys. They put these tantalum caps, which while incredibly stable, that's the only spec that Randall cared about, was its stability and how accurate the rating was on the barrel of it. He didn't bother the care that these things are incredibly susceptible to shorting if their rating happens to coincide with the rail that they're right next to. These always short to the rail and cause issues. Especially on, if you have a Boogie with a graphic EQ, look on the outputs of that thing, and these guys always short out. So, what's it gonna be? Let me see if I could run some tests here, see if we have a short anywhere around here, and maybe it's just that easy, right? So the symptoms as described would include having a muted preamp, because that's what some of these do. Some of these will be responsible for muting any switching sounds that's generated in the switching matrix. Okay, some of that, it could be some of that, but I'm not getting any audible hum or indication on the output that there's anything going on in the power amp. One of the problems that I would see with a lot of F50s is these are pretty stout screen grid resistors down here. Let me see if I can get you over it. But the problem is, because the thing is flex fit for stability, and you can see now, I'm gonna have to hold this up, it's gonna be shaky. You can see how they suspend the screen grid resistors, which is super cool. I love the way they did that, but you always see breaks in the PCB traces. So you'll lose a bank of screen grid resistors in the screen supply to the output tubes. So you'll get silence there as well. But that's not going to be coinciding or part of the equation or calculus with the switching matrix. It's just a different thing altogether. Now let me let go of this thing and set up the meter. And so I think this LM3914 logic chip is failing. That 6426 drive transistor right there next to my fingertip. If this test confirms that it's stuck latched, regardless of which channel is selected, then I need to replace this guy right here. All right, so it looks like this LM3914 is stuck at negative. It's not swinging this guy right here, or this 6426-4. That's the one that's driving the relay for the third channel, the red channel, and it's stuck on. So according to this test, it's not a power supply issue, it's that logic chip. And oddly enough, I don't have any shorted J175s, which is nice. So I don't have this on hand. I got to order it. Bye.